So I want to spend several minutes to talk about how AI changed some theory in corporate finance. So we have seen a lot of empirical evidence how AI replaced labor, how AI replaced human, but like theory-wise, how does the AI affects the traditional corporate finance theory and sometimes corporate governance theory? We don't talk about this. So if you are interested, please look at Professor Wei Zhang's review paper. She has a very detailed overview of how exactly AI changed the traditional theory of corporate finance and governance. I'm just do a little bit highlight uh, of what she wrote about and just provide examples, my industry observations for some of the points she raised. So, but you can refer to the original paper. But I want to raise some of the really interesting point she raised here. So, but before I do that, I just want to do a little bit summary of how exactly the AI research are classified into several categories. The first one is type 1 AI research in finance accounting. So AI is used as a tool to answer some existing questions. So for example, predicting stock returns or predicting restatement, it's a question for a while. So what we do is we're using AI to provide new answers to existing questions. This is type 1 research. AI is used as a tool. So what is type 2 question? Type 2 question is AI is changing our theory. AI is changing our life, and we want to address some questions contains AI. So for example, how humans should work with AI? How should corporate executives allocate jobs between AI and human? So these are the questions. The research question themselves contains AI. The third one is policy, how we regulate AI, how we make the AI efficient at the firm level and state level. So you can see that we have three types of AI. The first one, the question doesn't have AI, but using AI as a tool. That's type 1. Type 2 is we answer questions related to AI. So for example, I have a paper about like when managers they're trying to invest in AI projects, right? How to make optimal decision for AI investment, like which AI project they should invest, which and they shouldn't. So these are the type 2 questions, right? Type 3 is policy. So if you look at Wei Jiang's paper, they raise many questions in the type 2. In type 2. But you can see the literature. In the literature, majority of the study is on type 1. Because type 1 is more accessible scholars. If you're doing asset pricing, you can do type 1. If you're doing corporate governance, you can do type 1. But Wei Jiang's review paper raised a lot of type 2 questions for us to think about. I want to do 3 things from her review paper, and you guys can see the full paper. I just want to highlight 3 things. So she raised a new definition of, said, new boundaries of information asymmetric. It's called public information asymmetry. So basically AI redefined the definition of information asymmetric. That's very big. That's very big for the traditional corporate finance theory. And also AI accountability is also one new point she raised in her review paper. And also there's a misalignment between AI agent and human need, human demand. So these are the 3 points I want to use examples. I want to use industry observations to make sure everyone understands her point. And you can look at her paper to see more details and many interesting points. So I would conclude for the points she raised. Is this problem for computer science scholars or for finance scholars? So that's also we want to discuss about that as well. So what is redefined information asymmetry? What does that mean? So let's look at what is traditional information asymmetry. In her paper, she used a Tesla as an example. So the traditional information asymmetric is the information gap between the insiders and outsiders of the Tesla. That's traditional information asymmetry. But in the 2017, the outside analyst can use satellite image to get the Model 3 production. So what does that mean is this alternative data will allow the outsiders to have the information that is only available for insiders. So the AI and alternative data reduce the traditional information gap. That's one point she's raising. We can see that the information gap between the insider and the outsider was very large, but the AI reduced it. AI reduced it. But But the problem is, there will be a new information asymmetric in the age of AI. She called as a public information asymmetric. So what does that mean is, while the AI reduced in traditional information gap, widening the gap between the outsiders. What does that mean is there's some analysts who are able to use AI and set an image. They are retail investors. They don't have the resource to use the images. And the information gap between outsiders become larger. So that's called public information asymmetry, which means the information asymmetric is not between insider and outsider anymore. The information outsider become the outsiders who has the AI resource and who don't has the AI resource. So what is interesting here? So kind of when God closed the door, he opens another. So when AI closes the information gap, she opens another. So what is interesting here? What is unique here? So I just want to highlight some of her point. So what is unique here is in the traditional information asymmetric, the insiders and outsiders, they have different information access. The insider has preferential access to information. But in the public information asymmetric, we defined everyone has equal access to information. That's very interesting because in all the information asymmetric, insider has the information, outsider doesn't have. The information gap was defined by their different accessibility to information. But for the new information asymmetric, she defined everyone has the same right to download the website, to download the images. But the information gap is not arised from the differential access to information, but their differential power information processing. You can see that the new information asymmetric is not resulting from the information accessibility, but computational power. That's the fundamental nature difference between the two information asymmetric. So I want to talk about several papers looking at this. I think this is very interesting idea. So one paper is I wrote with Wei, and we find the empirical evidence, like if analysts can use this kind of alternative data, it kind of reduce the traditional gap, but you whitening the traditional gap and whitening the new gap, right? That's one paper. But I want to also talk about another paper, which people might be interested. It's called the Visual Information and AI Divide: Evidence from the Corporate Executive Presentations. So what we do is the CEO do a lot of presentations at investment banks. Sometimes is a roadshow, sometimes non-deal roadshow, sometimes just regular meetings with institutional investors. So what we did is they have the slides on their website. So we crawl all the slides, and on the slides there are many images, and we get all the images from their slides. The images has different images. There's an image about the products, image about the construction website, construction site, images about their future product, image about operations. So we get many of the images from the CEO slides. So what we want to do is we examining two questions. One is, are this image has value for the firm value? So if the image is useless, we shouldn't see the image affects the firm value. If the image is informative, and it should affect the market value of the firms. So we do find some images useful, some images not useful. Just for details, you guys can look at. But more interestingly is we echo Wei's point. We found the public information asymmetric. So we divide the investors into three groups: the institutional investor who can use AI, and the institutional investors who do not use the AI, and the retail investors who have no idea what is going on. So what we found is AI investors, they are trading on these images. They harvest great returns from these images. Non-AI investors, they kind of, they don't trade on images, but they have other resources. So they are not doing bad. They are doing okay because they have other resources. What I worry about is the marginalized retail investors. They have no AI, they have no other resource, they don't trade on images, they have no idea what is going on. So they are far behind this. And the gap between the retail investors and AI investors, the gap becomes larger and larger with the rising of AI and alternative data. So this is exactly what we're talking about, public information asymmetry. Because these AI hedge funds and the retail investors, they all have the access to download the company's website. No, but the one has the power to process all the slides and images. The retail investors may only can download 1 or 2 websites. So you can see that this is the public information asymmetric we was talking about, and it's happening right now by using the setting of the image. You can see that the gap, the information gap, is not inside and outsider. The information gap is between the AI hedge funds and the retail investors. And you can see that again, the unique difference between the two is they are not different. They are not resulting from the differential access to information. They are the divide is because they have different information processing power, and we call this AI divide. But in Wei's paper, she called it public information asymmetric. Basically, same thing, right? Same thing. So so this is where we have empirical evidence to support her point. And so any solutions? So one potential solution is called accessibility of technology. So what does that mean? So I want to give you guys some ideas. What do you mean by accessibility of technology? So a lot of people focus on AI, GPT, DeepSeek, but no one focus on the accessibility of technology. Let me give you guys an example. So Google BERT is a very powerful model, and some of the task performance is almost equivalent to GPT. But everyone knows ChatGPT, but very few people know Google BERT. Why is that? Google BERT is 4 years ahead of GPT. Why is that? Because when you use GPT, you have a web interface. Everyone can use it, easy. You don't need programming. But for Google BERT, you have to download it. You have to do the environment. You have to use Python to code it or R to code it. You just make the using it difficult. So this is called accessibility. How easy, how friendly to use technology. That's make a lot of difference. So so my view is the accessible AI can reduce the public information asymmetric way is proposing. So basically, the AI can reduce the traditional information asymmetric, but accessible AI can reduce the new information asymmetric. The way is proposing here. That's my conjecture. Might be wrong. So basically, the world is evolving, right? With the rising of AI, we reduce the traditional information asymmetric, but we have new information asymmetric. But with accessible AI, we can reduce the new gap. But maybe we create another gap as well. I don't know. But I just say a lot of points raised by Wei's paper deserve an independent working paper, I feel. So another one is AI accountability. So what does that mean in her paper? I want to use this kind of very briefly what middle-sized investment company is doing. In a middle-sized investment company, there are 4 steps. They select stocks, sometimes by AI, and then human is the gatekeeper. Human will make sure the AI selected correct stocks and no red flag, and then they do the risk control. When they add the stock into a portfolio, they make sure the risk is okay, and then they want to execute the trade with minimum cost. So these are the 4 steps of the middle-sized investment companies doing. And the first step is already AI. The second step is human. Human is gatekeeping the AI's output to make sure AI is doing the right job. So what is happening right now is because the human in the last 2 decades, human has all the nodes, how to monitor AI, how to do gatekeeping, how to make sure AI is doing the right job. With these nodes, we can retrain large language model. And after we retrain large language model, we don't need a human to gatekeeping machine. We can have just train the machine to gatekeeping machine. So that's that's what happening right now. Same as a risk. In the last 20 years, the human wrote a lot of risk notes, like how to control the risk, how to identify the risk, how to make sure the added stock do not violate the risk preference of the client. So human has a lot of notes on the risk control, and the AI can train on the notes. And once AI can train on the notes, AI can do the job the risk managers can do. So these are the two things. It's happening right now because the notes the human wrote in the last 2 decades. And with these nodes, we can train AI, and AI can replace the gatekeepers, and AI can replace the risk managers. But we always have like 1 people left in a game, And why is that? I'm not sure. And one point, I think a waste point is accountability. So the joke online is AI can do everything for you, but AI cannot go to jail for you. That's one joke people always do online. I think maybe that's the reason that we have a human to hold the accountability. When something goes wrong, someone has to take the fall. AI cannot take the fall. But I want to be open-minded. Maybe it's not AI accountability. Maybe the one people is the super smart people. The super smart people gatekeeping AI, who gatekeeping AI, right? This is maybe that's a possibility. So basically, they have one people left. Maybe it's for liability, or maybe just this is a super smart human who can make sure AI is doing the right thing. And the third point we raised, I think is very interesting. So she mentioned that AI create risk, kind of optimizing the objective. That may be conflict with broad welfare goals with long-term strategy. So what does it mean? That means what AI give to you is different from what you want. That's a very interesting question, because AI doing optimization, but what AI provides you may not be what you want. So then we have to go to the concept. What do you mean by ground truth? Defined by in the computer science. The ground truth means we need a correct training sample and the correct objective function for AI to do the right optimization. That's called the ground truth. So sometimes when human doesn't know what we want, and then AI doesn't know how to do the optimization, because the objective function will not be clear. So basically, the point here is we need a correct training sample. We need a correct, clear objective function to make AI to give you what you want. Let me give you guys some examples. Predicting stock returns. The objective is super clear. So what the objective of predict stock returns? You just want to minimize the prediction more errors. You want to maximize profit. So this one, the objective is very clear. The AI can do the optimization for you. So in that case, there's no confusion. Human know what we want. AI know what they are optimizing for. So this is a very clear example. There's no misalignment. But when do you have misalignment? Let's talk about the corporate governance decisions. We don't actually know what we want. Do we want, for any corporate governance decision, do we want to maximize shareholder value? Do we want to balance ESG? Do we want to DEI? Do you want to ethics? There's so many things going on right now. And even if you want to make everything happen, you want it all objective, what's the weight on each matrix? So it's not clear, even for human, what we want for the corporate governance decision. So that make AI confused. AI don't know. If AI just to optimize shareholder value, that's easy, but it's not simple like that. It's not simple like that. That's why, I always push back. We have a lot of we have very strong school at Maryland, engineering school at Maryland. Sometimes we are thinking about, is our business school too soft? Like we don't create, like our issue is too easy, and we don't create a really good social product. I feel what we studying for is human. It's much more complex than some engineering problem. So let's look at the rocket launches. For rocket launches, the objective is very easy, right? It's very objective. We want a successful launch. We want no failure. So we have a clear objective for that. Even the procedure is complicated, but nature of human is very complicated. Do you know what you want in life? If you don't know that, it's very difficult for us to guide AI to optimize it. So to that degree, I feel like what we are studying can be more complicated than some of the engineering problem, because engineering problem, the objective is very clear. Is the procedure very complicated? But for us, even the objective is not clear. So in that case, how we can rely on AI? The waste point is we cannot. You will have misalignment. So AI will struggle to find the correct training sample and from the historical governance decision. What does it mean? So normally we have the training sample to guide AI. So basically, if you know in your past governance decision, if it's a correct decision and wrong decision, and you can using the correct decision and the wrong decision to train AI, but we don't know which decision is correct, which decision is wrong. So in that sense, there's no way we can train AI with that. So for example, the board members made many decisions in the past, and we have to tell AI these decisions are true decisions, correct decisions. These decisions are wrong decisions. We have to define it and train AI, but we cannot even define it. In the history, we don't know which decision is correct, which is not correct. So the point I think here is there will be misalignment between what AI provides you and what you want. And the reason because we are not sure about what we want. We are not sure about what's the objective function of AI. So this is very interesting perspective raised by Wei. So I think the some misperception in literature is AI is the God. Whatever AI provides you is the optimal. But Wei's point is not. What AI provides you is not optimal. AI provides you might not be what you want. So this kind of challenge a lot of assumption in the current literature, because we believe human has a bias, and what AI provide is the benchmark, is the optimal. What we trying to say is not. It's not because the human doesn't know what we want. So AI also doesn't know what they are optimized for. So what AI provide may be optimal, but maybe misalignment with human demand. So this is a very interesting point. So going back, what's the problem for? Is the problem for computer science scholars? Or a problem for us? Like, do we just need to rely on the computer scholars to develop a genius system to resolve all the issues we talked about earlier, 3 points, or need the finance scholars, accounting scholars to do this? We can come down to like for AI competition, we have 3 ways to compete. You develop a good algorithm. You have the computational power. The third one, you have a domain knowledge about the institutional details and data. So what's the competition here is for finance domain, the algorithm design is less relevant because most of the algorithm is public available. So look at the self-attention, transformers. All this algorithm is actually public available. So it's less relevant to us. Computational power, relatively, finance has a small data relative to physics. So, but what's important in order to resolve all the issues above, we need domain knowledge about institutional details of the data, of the setting, of the theory. So that's what finance scholars, accounting scholars can chip in. So with all respect, so earlier we talking about the CEO presentation slides. We talk about AI analysts. Do you think, computer science scholars will understand this data? I was a computer scientist before I do a PhD in business. I have no idea what is the CEO presentation slides. I have no idea who are analysts. So this domain knowledge, institutional knowledge, is very challenging for CS scholars, but these are critical for us to develop the tools to resolve the issues raised earlier. So the point here is, it's our job to resolve all the issues, the AI plus finance issues. And that's why Wei and we and Li Jun, we wrote a textbook. The textbook will help people to understand the data, understand the institutional background. I will talk about the book later on. But the point here is, in order to resolve all the issues raised earlier, we need domain knowledge. We need an understanding of data, and it's hard for computer scientists, and it's easier for finance. And right now, we have a lot of pre-trained model, so the technology barrier is going down and going down. So what's the future? Let's talk about what's the future. The future is, you guys look at some news. The AI can serve as a board member. So you can see that the China-based NetDragon, they appoint AI program as CEO, named Tang Yu. So basically the AI is managing the firm as a CEO. So what's the purpose of the AI CEO? I mean, there's many conjectures. One is just marketing, right? Another one is functional. Maybe the AI can make a better decision than human, maybe. Or going back to Wei's point, accountability. Someone has to take the fall. If the AI CEO, AI take the fall. So I mean, I feel there's many interesting stuff people can explore here, but this is some of the new stuff going on in the society, and we can look into it, right? So why some firms appoint AI agent as a CEO or board members? So this is one future direction. Another future direction, I want to point out the interesting paper by the Ariel. So basically, what they do is they use AI to select board members. And then compare with human selected board members, they can see what is going on. So you can see these are the two things, happening right now can be, what future interesting inquiries we can explore. Either AI will act like board members, or we're using AI to select board members. So many interesting stuff going on right now. So I want to conclude with the textbook. On Amazon, you guys can download the textbook, but if you download from Amazon, you have to pay 1.99. You can go to my website, you can download, it's free. And of course, if you want to use Kindle, you can spend 1.99. So we have also hard copy. The hard copy is 7.99. It's out of stock. The book is getting popular. So but wait a little bit. You have a hard copy. If you have a hard copy, you can 7.99. Hopefully that's not huge money for us. But the free version available online. And again, we have only 5 reviewers who wrote the reviews. I hope more people can write the reviews, and you can write bad reviews too. You don't have to write good reviews. But Amazon is control the review quality. So if it's too simple, a good book, blah blah, maybe they will block it. So there's a reviews you guys can check into, and the book is unique. It's not we don't start with Python, TensorFlow. We start from the data. We help people to understand the annual report, conference call. And then we start introduce large language model. We teach you what is prompt engineering. We teach you what's fine tune of large language model. And then you can use the book for a new course. I use the book for a new course at Maryland. Or if you teach a traditional course, you can use the 1 or 2 chapters for a traditional course.